Hello students, today we will be solving Pure Maths Paper 1, Variant 1 from October-November 2016. Question number 1. Express x squared plus 6x plus 2 in the form of x plus a whole square plus b, where a and b are constants. So that means this is the completed square form, so we have to convert this into this form. So x squared plus 6x plus 2, we will be taking just x and then the positive sign, and 6 divided by 2 is 3, so it will be x plus 3 whole square minus 3 whole square plus 2. Simplifying this, we get x plus 3 whole square minus 9 plus 2, which is x plus 3 whole square minus 7. In the second part of the question, it says, hence or otherwise, find the set of values of x for which x squared plus 6x plus 2 is greater than 9. So what we can do, we can also think of x squared plus 6x plus 2 greater than 9, which is x squared plus 6x minus 7 greater than 0. So x squared plus 7x minus x minus 7 greater than 0. So we have done the middle term break. So if we take x common, it becomes x plus 7. And if we take negative 1 common, then we get x plus 7 again greater than 0. So that means x minus 1 and x plus 7 is greater than 0. Therefore, the critical values are x is equals to 1 and x is equals to negative 7. So since it's greater than 0, that means with the help of the number line, and since it's a positive quadratic equation, that means it will be U-shape. Therefore, for greater than 0, x must be less than negative 7 and x must be greater than 1. Question number 2. Find the term independent of x in the expansion of 2x plus 1 over 2x cubed whole to the power 8. So independent of x means x to the power 0, the term which will not have x. So the formula is 8CR 2x to the power 8 minus r and 1 over 2x cubed whole to the power r. So first we need to figure out what will be the value of r, which will eventually lead me to getting the independent term of x. So let's isolate the x terms only. So that will be, from this we get x to the power 8 minus r times x to the power negative 3r, because x cube is in the denominator. So 3 times r is 3r, and since we will be bringing it to the numerator, it will be negative 3r. This must be equal to x to the power 0. So since there is a multiplication, that means the power will be added. So x to the power 8 minus r plus minus 3r is minus 3r equals to x to the power 0. Simplifying this, we get x to the power 8 minus 4r, and with the help of the equality power rule, we get that 8 minus 4r is equals to 0. So 4r is equals to 8, therefore r is equals to 2. So now we know the value of r, which we can simply substitute into this formula to get the term which is independent of x. So 8c2 times 2x to the power 8 minus 2 times 1 over 2x cubed whole to the power 2. So it will be 28 times 64x to the power 6 times 1 over 4x to the power 6. And as you can see that x to the power 6 and x to the power 6 cancels out, and we are left with the term which is independent of x, which is 448. Question number 3. In the diagram OCA and ODB, so OCA and ODB are radii of a circle with center O and radius 2r centimeter. So the radius is 2r centimeter. Angle AOB is alpha radians. This is the angle. So CD and AB are arcs of circles with center O and radii r centimeter and 2r centimeter respectively. The perimeter of the shaded region ABDC, this is the shaded region, is 4.4 r centimeter. So the perimeter of the shaded region is 4.4 r centimeter. So with the help of this information, we are required to find the angle alpha. So we can see that this is R, so that means this is also R. Let's find the arc length CD and the arc length AB, and then we will sum all these sides, which will be equal to 4.4 R centimeter. So arc length AB, for this we have to think of the bigger sector, and the formula for arc length is R theta, where R is 2R and theta is alpha. So that will give us 2R alpha. And for the arc length CD, which is the smaller sector, it will be just R times alpha, which is R alpha. So the perimeter ABDC is equals to 4.4R. Therefore, R alpha, which is this, plus R, so R alpha plus R plus 2R alpha plus R gives us 4.4R. Or we can say 3R alpha plus 2R is equals to 4.4R. If we take R common, we get 3 alpha plus 2 is equals to 4.4R. So 3 alpha plus 2 is just 4.4. We are dividing both sides by R. Now we are left with 3 alpha is equals to 2.4. Therefore, alpha is equals to 0.8. In the next part of the question, it is given that the area of the shaded region is 30 centimeters square. We need to find the value of R. So we are now provided with the area of the shaded region. So for that, how will we be finding the area of the shaded region? So we have to plan that first. So our objective should be finding the area of the bigger sector and taking away the area of the smaller sector. That will leave us with the area of the shaded region. So area of the sector OAB, which is the bigger sector, must be half R squared theta is the formulas, where R is 2R and theta we got 0.8. So that gives us 1.6R square. And area of the sector OCD is half R square. Again, the theta is 0.8. That gives us 0.4 R square. So according to the question, which that is the area of the bigger sector minus the area of the smaller sector is equal to 30. So 1.2 R square is equals to 30. Therefore, R square is equals to 25. So R will be the square root of 25, which is 5. And we will be only considering the positive value because radius cannot be negative. Question number 4. C is the midpoint of the line joining A and B, where A is 14 and -7 and B is -6 and 3. The line C, perpendicular to AB, crosses the y-axis at D. We need to find the equation of the line CD, giving our answer in the form of y is equals to mx plus c. So let's first find the gradient of AB. So we will be using the formula y2 minus y1 over x2 minus x1. That gives us 3 plus 7 and -6, -14, which comes down to -1 over 2. So the gradient of the perpendicular bisector must be the negative reciprocal of this number, which is positive 2. And since we are talking about the perpendicular bisector, that means the line must be going through the midpoint of AB. So we must find the midpoint of AB. So we will be using the formula x1 plus x2 over 2, comma, y1 plus y2 over 2. So that gives us 14 minus 6 over 2, comma, minus 7 plus 3 over 2, which is 4 and -2. So now we have a coordinate through which the line will be passing through, and which is the perpendicular bisector. And we also have the gradient for the perpendicular bisector. That means we can use the formula y minus y1 is equals to mx minus x1. So y minus -2 is equals to 2x minus 4. That gives us y plus 2 is equals to 2x minus 8. That means y is equals to 2x minus 10. And we have expressed the equation of the line in the form of y equals to mx plus c. Moving on, for the second part of the question, we need to find the distance AD. So we know that, as it is mentioned in the question, for point D, it crosses the y-axis at D, and we know that at y-axis x is 0. So we at least know the x coordinate of the point D, which is 0. So D must be 0 and y, and the equation of the perpendicular bisector was 2x minus 10. So since this point lies on this line, it must satisfy the equation. So we can substitute the value of x into this equation to find out the value of y. So x is equals to 0. That means y is equals to 2 times 0 minus 10. That gives us y is equals to negative 10. Therefore, the point D must be 0 and negative 10. So we have the coordinate of D, and we are already provided with the coordinate of point A. So now it is easier for us to figure out the distance. So the distance AD will be, the formula is square root of, so the formula will be square root of x2 minus x1 whole square plus y2 minus y1 whole square, where it will be 0 minus 14 whole square plus negative 10 plus 7 whole square. So that gives us square root of 205, which is 14.3. Question number 5. The sum of the first and second terms of a geometric progression is 50, and the sum of the second and third terms is 30. We need to find the sum to infinity. So since it's a geometric progression and they are stating that we have to find the sum to infinity, that means it does exist. So that means the value of r must be a proper fraction, which lies between -1 and +1, or else the sum to infinity will not exist in the first place. So according to the question, the sum of the first and second term means a plus ar, this is the first term and this is the second term, is equals to 50. And the second and third term, when you sum them, you get 30 square, 30. So let's simplify this. We can take a common and it will be 1 plus r equals to 50. So 1 plus r is equals to 50 over a. And for this, if we take ar common, we get 1 plus r equals to 30. Let's call this equation 1 and this one equation 2. Now we can simply substitute this equation into this, and we will be able to figure out the value of r and a. So we can say ar times, instead of 1 plus r, we can write 50 over a is equals to 30. So 50r is equals to 30. Therefore, r must be 30 over 50, which is 3 by 5. Now let's call this equation 3. Now in order to find out the value of a, we can use this into the equation 1. So 1 plus r is equals to 50 over a, where r is 3 over 5. So 1 plus 3 over 5 is equals to 50 over a. That means 8 over 5 is equals to 50 over a. So 8a is equals to 250. Therefore, a must be 31.25. Now, to find the sum to infinity, the formula we'll be using is a over 1 minus r. So a is 31.25 over 1 minus r, which is 3 over 5. That gives us 78.125. Question number 6. Show that cos to the power 4x is identical to 1 minus 2 sine square x plus sine to the power 4x. So considering the left hand side, which is cos to the power 4x, cos x to the power 4, so we can take the power 2 outside and make this cos square x. So this can also be manipulated as 1 minus sine square x whole square. So this will be, if we use the formula a minus b whole square, we will be getting 1 minus 2 sine square x plus sine x to the power 4, which is equals to the right hand side. In the next part of the question, it says, hence or otherwise solve the equation 8 sine x to the power 4 plus cos x to the power 4 is equals to 2 cos square x, where x lies between 0 and 360 inclusive. We have already proved that cos to the power 4x, cos x to the power 4 is this. So we can substitute this into cos x to the power 4. So that will give us 8 sine x to the power 4 plus 1 minus 2 sine square x plus sine x to the power 4 equals to 2 cos square x. If we take away the brackets, we will get this. And then if we simplify further by manipulating cos square x as 1 minus sine square x, so now we have converted all the value, or you can say all the identities, to sine square x in the sine format. So we will be having 8 sine x to the power 4 plus 1 minus 2 sine square x plus sine x to the power 4 minus 2 plus 2 sine square x. So we have negative 2 sine square x and positive 2 sine square x, so they will cancel out. Then we are left with 9 sine x to the power 4 minus 1 equals to 0. That means sine x to the power 4 is equals to 1 over 9. That means sine x is equals to plus minus 1 over root 3. Let's find the basic angle now. So we will be ignoring the negative side, the negative sign. So that gives us alpha is equals to sine inverse of positive 1 over root 3, which is alpha is equals to 35.264. Now let's consider what will happen when sine is positive. When sine is positive, it lies in the first and second quadrant. And the limit that we were provided with was x lies between 0 and 360. So we can take both of these quadrants. So for the first quadrant, the basic angle will be the actual angle, which is 35.3 if you correct it to 3 significant figure. And for the second quadrant, it will be 180 minus the basic angle, which is 144.7. Now when sine is negative in the third and fourth quadrant. That means we will be getting the value for third quadrant by 180 plus the basic angle, which is 215.3. And for the fourth quadrant, it will be 360 minus the basic angle, which is 324.7. So these are the x values that they are looking for. Question number 7. The diagram shows part of the curves y equals to 2x minus 1 whole square and y square equals to 1 minus 2x. Intersecting at points A and B, we need to state the coordinates of A. So what we can say for sure that A, since A is on the x-axis, that means y must be 0. So at A, y is equals to 0. And let's use this equation to find out the coordinate of A. So the formula is y is equals to 2x minus 1 whole square. And now let's substitute y is equals to 0 into this equation. So 0 is equals to 2x minus 1 whole square. So 0 is equals to 2x minus 1. So 0 is equals to 2x minus 1. So x is equals to half. So the coordinate must be half and 0. In the next part of the question, we are asked to find, showing all necessary working, the area of the shaded region. So let's plan first how to find the area of the shaded region. We know that in order to find the area from the graph, we need to integrate the equation of the curve. And while doing that, we get the area between the curve and the x-axis. So if we find the area using the curve y square equals to 1 minus 2x, we will be getting the area between the curve and the x-axis, this whole region. We will be getting this whole region. So later what we can do, we can find the area between this curve, which is y is equals to 2x minus whole square, and that will give us the area between this curve and the x-axis, which is just this white region. So we can take away the this area from the whole area which lies under this curve. Then we will be left with the area of the shaded region. So, but first we have to fix a few things. We were provided with one of the equation, which was y square equals to 1 minus 2x. So let's change it to y. So y will be 1 minus 2x to the power half. So basically I'm just square rooting both sides. That gives us y is equals to 1 minus 2x to the power half. Now, as I told you, so we need to integrate and we need to take away this area from 1 minus 2x to the power half. So let's integrate now. So first we have the power operator. That means this is the box, and if we differentiate it, we get -2. So -2 will be here, and in order to balance the equation, it will be 1 over -2. And for this part, again, power is the operator. That means 2x minus 1 is the thing that we need to differentiate. That gives us +2. And to balance it, we need +½ outside. Then for both of these, the integral sign, differentiation of the box, and dx will go away. Then we will be left with -½ times 1 minus 2x, and then we can, of course, integrate the operator, which will be half plus 1, which is 3/2, and then we will be having 3/2 in the denominator as well, minus half times 2x minus 1 to the power 2 plus 1 is 3, and we will be having 3 in the denominator as well, plus c. So simplifying this further, we get -1 minus 2x to the power 3/2 over 3, negative 2x minus 1 to the power 3 over 6 plus 6 plus c. So for the required area, we need the limits half and 0. Half was the x coordinate of point A, and you can check the graph again. So this is half and this is 0. So we simply have to substitute these two values into this equation, and doing so, we will be getting the area, which is 1 over 6. Question number 8. The functions f and g are defined by fx is equals to 4 over x minus 2 for x is greater than 0, and g of x is equals to 4 over 5x plus 2 for x is greater or equal to 0. We need to find and simplify an expression for fgx, and we need to state the range of fg. So for fgx, that means this equation is getting substituted into this x. So it will be 4 over 5x plus 2 minus 2. Simplifying this, we get 5x plus 2 minus 2, which is 5x. And this is the equation of a straight line which passes through the origin. For this, you must have the knowledge of the common graphs. We know that y equals to x is a line which passes through the origin, and that means y equals to 5x is going to be such a line which will have a steeper gradient. So it will be something like this. And since x is greater than 0 for both the case, of course, that means the domain will start from here, and the range will be above. The positive x-axis, but the positive y-axis is the range. So for the range, it will be fgx is greater or equal to 0. In the next part of the question, we need to find an expression for g inverse of x, and we need to state the domain of g inverse. So first, let's consider y is equals to gx. So y is equals to 4 over 5x plus 2. Now let's make x the subject. So for doing that, we need to first cross multiply, and it will be 5x plus 2 is equals to 4 over y. So 5x equals to 4 over y minus 2. That means 5x equals to 4 minus 2y by y if we do the LCM. So x will be 4 minus 2y over 5y. Now, since y is equals to g of x, that means g inverse of y is equals to x. Therefore, g inverse of y is equals to 4 minus 2y over 5y. Therefore, g inverse of x must be 4 minus 2x over 5x. Now, when x is equals to 0, let's find out what is the range of gx. So when x is equals to 0, gx equals to 4 over 5 times 0 plus 2, which gives us 2. The reason why we did this is because the domain of g inverse is the range of g of x. Okay. And not only that, at the same time, you have to have the knowledge of how the graph of 1 over x looks like, because this is 1 over x is similar to 4 over 5x plus 2. Like the shape of the graph is quite relevant to this information. So 1 over x looks like this. The graph of 1 over x looks like this. And also, we will be considering the domain as x greater than 0. And we can see that when we have substituted x, when we substituted x is equals to 0, we got that gx is equals to 2. That means this is the point where the graph will intersect the y-axis. And since x is greater than 0, we will be ignoring this side of the graph, the left side, from the y-axis, and we will only be taking the right side of the graph. So as you can see, the range, as x increases, the range lies between 0 and 2. In the y-axis, the range is 0 and 2. So the domain of G inverse must be x lies between 0 and 2 inclusive. The reason why we have excluded 0, because as you can see, okay, so the reason why we have not included 0 and we are stating that x lies between 0 and 2, where 2 is inclusive and 0 is not inclusive, is very important, because as you know that the graph of 1 over x looks like this. Similarly, when we substituted x equals to 0 for g of x, we got this, which is 2. The range is 2. So for this part of the graph, this curve will never meet x-axis. It will never meet x-axis. So it will never be 0. It will keep on getting closer and closer to 0, but it will never be 0. That is the range I'm talking about for g of x. When we have the domain x greater or equal to 0 for g of x, we will never be getting the range as 0. It will be above 0 but less than 2. So it will be between 0 and 2, where 2 is inclusive but 0 is not inclusive for the range. Similarly, the domain will be x lies between 0 and 2, where 2 is inclusive but 0 is not. And you have to make sure that you are giving proper inequality, or else you will not be getting marks for this. Question number 9 is related to vectors, which is not in the syllabus at the moment. Question number 10, a curve has equation y is equals to fx, and it is given that f prime x is equals to 3x to the power half minus 2x to the power negative half. The point A is the only point on the curve at which the gradient is negative 1. We need to find the x coordinate of A. So f prime x is negative 1. That means this equation is equals to negative 1. Or we can say 3 root x minus 2 over root x, because there is a negative half, is equals to negative 1. Then if we do LCM, we get root x, and root x times root x becomes just x. Minus 2 is equals to negative 1. That means 3x minus 2 is equals to negative root x. Then we can say 3x plus root x minus 2 is equals to 0. And you should be able to recognize that this is a quadratic equation. Now let's use substitution method to solve this. So we will be considering a as root x. So 3a square plus a minus 2 is equals to 0. Because if you square this, you get just x. So now you will be using the middle term break. So it will be 3a square plus 3a minus 2a minus 2 is equals to 0. Taking 3a common, we get a plus 1. And if we take negative 2 common, we get a plus 1 again, which is equals to 0. So 3a minus 2 and a plus 1 are the factors, which is equals to 0. Therefore, a must be 2 over 3 and a must be negative 1. That means square root of x is 2 over 3 and square root of x is negative 1. Now squaring both sides, we get x is equals to 4 over 9 and x is equals to 1. But that's not it. This is not our final answer, because you have to look at the question carefully. It says that the point A is the only point on the curve. So they're talking about just one point. So let's put it to test these two values into the differentiated equation, because f prime x basically means first derivative. So when x is equals to 4 over 9, if we substitute this into this equation, we get negative 1. But when we substitute x equals to 1 into this equation, into the same equation, we get positive 1. That means this does not support the statement, which is if we substitute the x value, we will be getting negative 1. It only supports for the value x equals to 4 over 9. So our final answer must be x is equals to just 4 over 9. The reason why we got two values, because it was a quadratic equation, and the nature of a quadratic equation, one of the nature of a quadratic equation is that you will be getting two different values. Moving on, in the second part of the question, given that the curve also passes through the point 4, 10, that means this point must be satisfying the equation of the curve. We need to find the y coordinate of the point A, giving our answer as a fraction. So this was the differentiated equation, which was f prime x. Now let's integrate this equation, which will help us to get the equation of the curve. So for integrating, by integrating, we will be getting half plus 1 is 3 by 2, and in the denominator it will also be 3 by 2, minus 2x to the power minus half plus 1 is just half over half plus c. Simplifying this, we get y is equals to 2x to the power 3 by 2 minus 4x to the power half plus c. Now let's substitute this value of x and y into this equation to find out the value of the constant c. So 10 is equals to 2 times 4 to the power 3 by 2 minus 4 times 4 to the power half plus c. So 10 is equals to 16 minus 8 plus c, therefore c must be 2. So the equation of the curve must be y is equals to 2x to the power 3 by 2 minus 4x to the power half plus 2. Now we have the equation of the curve. We just have to find the y coordinate of A, which also lies on this particular curve. But we already know the x value for that point. So we can substitute this into this equation to find out the value of y. So it will be y equals to 2 times 4 over 9 to the power 3 by 2 minus 4 times 4 over 9 to the power half plus 2. Simplifying this, we get 2 times 8 over 27 minus 4 times 2 over 3 plus 2. That gives us y is equals to negative 2 over 7. So this is the y coordinate of the point A that they are looking for. Question number 11. The point P, 3, 5 lies on the curve y is equals to 1 over x minus 1 minus 9 over x minus 5. We need to find the x coordinate of the point where the normal to the curve at P intersects the x-axis. So for this, you need to have an idea of what they're talking about. So let's consider this to be the y-axis and x-axis. This is just for explaining reasons. And let's say this is the curve that they're talking about. So we know that normal, which is this line, is perpendicular to the tangent, which is the green line. So they're saying that the point P lies on this curve, and we need to find the x coordinate of the point where the normal to the curve at P. So normal to the curve at P, let's consider this to be the P point, which is 3, 5, and the normal to this curve at P intersects the x-axis. So we need to find this point. So this is the equation of the curve. We need to differentiate this first. That way we will be getting the gradient of the tangent when x is equals to 3. So differentiating this, so first we need to differentiate the operator, the power, which is minus 1 is negative 2, and minus 1 times positive 1 is negative 1. So it will be minus x minus 1 whole to the power negative 2, and then inside differentiation for x will be just 1, and negative 1 times negative 9 is positive 9. Then it will be x minus 5 to the power negative 1 is negative 2, and inside differentiation x will be just 1. Simplifying this, we get 9 x minus 5 whole to the power negative 2 minus x minus 1 whole to the power negative 2. So when x is equals to 3, when we substitute this value into this equation, we get 9 over 4 minus 1 over 4, which is 2. This is the gradient of the tangent. So the gradient of the normal must be negative reciprocal of this number, which is negative half. And we already know the point through which the normal will be going through, which is 3, 5. So we have the coordinate and we have the gradient. So we can use the formula y minus y1 equals to mx minus x1 to find the equation of the normal line. That will be y minus 5 equals to minus half times x minus 3. Simplifying this, we get 2y minus 10 is equals to negative x plus 3. So 2y plus x equals to 13. This is the equation of the normal, equation of this blue line. Now we simply have to substitute the value of y, which is equals to 0, in this equation to figure out the value of the x coordinate. And the reason why we will be using y is equals to 0 because at x-axis y is 0. So substituting this value, we get x is equals to 13. In the next part of the question, we need to find the x coordinate of each of the stationary points on the curve, and we need to determine the nature of each of the stationary point, justifying our answers. So at stationary point, we know that dy by dx is equals to 0. So this equation must be equal to 0. This is the equation of dy by dx we found in the first part. So this must be equal to 0. After doing LCM, we get 9 times x minus 1 whole square because we don't have x minus whole square in the denominator. And it will be minus 1 times x minus 5 whole square because we don't have this in the denominator, equals to 0. Now, after cross multiplying, this whole thing becomes 0. So it will be just 9 times x minus 1 whole square minus 1 x minus 5 whole square equals to 0. So 9 times x minus 1 whole square is equals to 1 x minus 5 whole square. Then we can say x minus 1 whole square over x minus 5 whole square equals to 1 over 9. Or we can say that by square rooting both sides, by taking power of half on both sides, that will help us to get rid of this power of 2. So it will become x minus 1 over x minus 5 equals to plus minus 1 over 3. Now, if we use the value positive 1 over 3, we get 3x minus 1. 3 times x minus 1 is equals to 1 times x minus 5. So 3x minus 3 is equals to x minus 5, and 3x minus x equals to 3 minus 5. That gives us 2x is equals to negative 2. That means x must be negative 1. And when we consider this whole equation is equals to negative 1/3, we get 3 times x minus 1 equals to negative 1 times x minus 5, which gives us 3x minus 3 equals to negative x plus 5. So 3x plus x equals to 3 plus 5. So 4x equals to 8. Therefore, x is equals to 2. Now, since dy by dx was this, we need to find the second derivative. And after doing that, we will be substituting the values of x that we got, which was minus 1 and 2, to find the nature of the stationary point. And at these two x values, the stationary point occurs. We just have to find the nature of these two stationary points. So for differentiating further, we need to multiply negative 2 with 9, which gives us negative 18. X minus 5 to the power minus 2 minus 1 is negative 3. And inside differentiation gives us 1. And negative 2 times negative 1 is positive 2. X minus 1 to the power negative 2, negative 1 is negative 3. Times inside differentiation gives us positive 1. So we can write it as 2 times x minus 1 to the power negative 3 minus 18 times x minus 5 to the power negative 3. Now let's substitute these two values. When we substitute x equals to negative 1 into this equation, we get negative 1 over 6. Since this value is less than 0, that means the nature of the stationary point when x is negative 1, it will be a maximum point. And when we substitute x equals to 2, we get positive 8 over 3. That means the nature of the stationary point when x is equals to 2 is a minimum point. And that will be all for now. I will see you in the next video.